Hello everyone. Today we will see that how the external quantum efficiency varies with respect to the absorption coefficient of the bottom layers, especially in the perovskite solar cells. In this case, let's say we are taking the electron transporting layer as an example. So we have seen this AMPS simulation before. So we need to put the ambient condition. Let's say we have light on and we want to check the quantum efficiency effect, and let's say okay, then we need to load our concerned device. In this case, let's say I have saved this device with the name of absorption of the ETL. Let's say we have this ETL and we don't take into account the absorption coefficient of this material. It may be titanium. In this case, it may be tin oxide, it may be zinc oxide. So this is perfectly transparent, which means it will not absorb any light, incoming light. So let's see what is the EQE of this specific device. We will go to the results and we will go to the quantum efficiency. Let's say copy the data, and at the last we will compare what will happen if we take into account the absorption of the material. Let's say in this case this was Control V. Okay, sorry, we should put this over here. Okay, this one. Okay, I think now we need to change some of the parameter over here. Now go to the here. This is the optical absorption. Now the amps have some built-in file. Let's say go to the absorption coefficient, and we consider that this, let's say this is the zinc oxide, and zinc oxide has some absorption coefficient over here. This is the wavelength range and this is the absorption coefficient. Let's say okay and run the simulation. We will see the result of EQE, and let's say over here. Now copy the data and put it over here. This is for the another absorption, and for example, let's say now take another one over here. In this case, for example, tin oxide, which is an ETL for the perovskite solar cells. Okay, and run the simulation. Now let's say check it the external quantum efficiency, copy the data, put it over here. Okay, now we will compare all the and let's say draw this one. Oh, sorry. This is x-axis. Now if we compare, I will just enlarge the size so that we can see the effect of the absorption coefficient of different material, which is important for the ETL in this case. Now if we look at this region, like in it 200 nanometers, this is the wavelength. Okay, this is the wavelength of the incoming light. This is in nanometers, and this one is the intensity of the EQE percentage, as we know that this is the percentage in this case. Now if we look at this region 200 nanometer to 400 nanometer, so in the first case this no absorption was taken in this case, but in the second case it was zinc oxide, in the third case it was tin oxide. So it means some of the light will be absorbed by these ETL, which may affect the performance of the solar cells. And so that's why the researchers take into account the absorption coefficient of the ETL. In order to get the high performance of the perovskite solar cells, so we need to have the transparent ETL so that we can have maximum incoming light, and that can be utilized by the active layer, which is the perovskite layer in this case. And thank you so much, and please subscribe my channel and let me know in the comments box if you have any doubt in this absorption coefficient analysis with respect to the materials.